Factoring polynomials. So when you have two cubes subtracted by each other, like a cubed minus b cubed, you have to put it into a format to factor it. So, and this looks like a minus b parentheses a squared plus ab plus b squared, and this is just a perfect square trinomial right here, and that is how you would factor a difference of cubes problem. Now, for perfect square trinomials, you have a perfect square trinomial, a squared plus 2ab plus b squared, and you're going to put it in, you're going to make it look like a plus b parentheses squared. When you're factoring a perfect square trinomial, all you're really doing is using the FOIL method in reverse. And what I mean by this is when you're foiling something, you will take two binomials multiplied by each other, and through the multiplication you will wind up with a trinomial. Well, this is the opposite. You're taking a trinomial, factoring it into two binomials. Factoring completely, essentially the same as factoring a perfect square trinomial. It's just going to have like one more number you can take out of it, so it's a little more complex. Factoring by grouping, you're going to have something like ax plus 2a minus bx plus 2b equals a times x plus 2 minus b times x plus 2. And since there are two x plus 2's, you only have to write one of them. And then you just group again the a minus b like so. So, it's not too hard. Just group everything properly. Example 1, x cubed minus 27. Well, they're both perfect. They're both cubes, and we're subtracting, so it's a difference of cubes. So we're going to use this formula to factor. And I've already defined what the a in this is for this problem. A equals x, b equals 3, and these are just both the cube roots of these numbers. So now we just have to plug these numbers into this using basic algebra knowledge. So x minus 3 times x squared plus 3x plus 9. And then that's pretty much it. You don't have to do anything else to that. It's factored properly. This is a perfect square trinomial, so you're going to use the reverse of the FOIL method to do it, and we have c squared plus 5c minus 50. And so when you're doing this, you just figure out the factors of this number, but here's the trick: they have to add up to this number right here, this 5 in this case, right? So what are some factors of negative 50? And since it's negative, I'm going to have one negative factor and one positive. Well, 5 and 10, if I put a positive 10 and a negative 5, and then I combine these, add them, I'm going to end up with a positive 5. So now I just go c plus 10, c minus 5. And that is two binomials, and if you were to FOIL this, you'd end up with that. And if you want to check your work, you can FOIL it, but this is what they want. They just want that factored form of it, and 10 times negative 5 is 50, 10 plus negative 5 is 5. So those aren't too hard. This is a factoring completely. So we're going to take, this is just making things a little more complex for us. We're just going to figure out, well, let's see, all of these are divisible by 3, so we can take it out. That's a 3, x to the 4th minus 20x squared plus 64. So now there's one more thing we can do, and this is just to figure out what factors, if there are any factors of 64, if we can simplify this any further. So we're trying to figure out the factors of 64, and some of them are, let's see, 8, and 8 will do it. 2 and 32 will do it. 4 and 16. Oh, let's look at that. 4 and 16, I like that, because we're trying to get this to combine just like we were doing before. So these, if we make these both negative, then we'll end up with a positive 64, because a negative times a negative is a positive. And if we add these, we'll get a negative 20. So that's exactly what I want. Now, because this is x to the 4th, these are both x squared, and then minus 4 x squared minus 16. And then there's the 3 in front of that, and that is the factored form of this. So you're just taking out this first number. And often, a lot of the times, you can tell if it's a factoring completely, because if something is in front of this x, because x always comes first in one of these, if something's in front of that, chances are you'll be factoring out this number. It's not always the case, but a lot of the time in problems like this one, that's what you're doing. Please. So, this is a factoring, let's see, factoring by grouping, right? Essentially the same as this right here. So we can group this, and when we do, we're just going to factor out the common terms in these two terms. And these both have a's. These both have 4's, negative 4's, but then those two don't really have anything in common. So we're going to put the b's, group them, and it's going to look like a, c, minus 4a. I'm not really switching around the order for anything, plus b, c, minus 4b. And then I can take out the common things, like a, c minus 4, plus b, c minus 4. And then, like I said, there's one more step, and it's just to put it like that. And that's as simple as you get. So that is the simplified form of this polynomial. So that's pretty much how you do these. They're not too hard. Fairly simple algebraic knowledge is all that's required. So I hope that helps.